Okay, so I think I'm working now. Welcome. I've had a few questions already for some maths via email. So as I promised to them, I usually like to answer emails first through the video, and then once I've gotten through those, I will then pass it to the I'll pass it on to the people who are in the chat, if there's anyone here. So I had a question from Bob. He emailed me, and he would like some further clarification on how to add and subtract integers, specifically combining together with negatives. In grade 7, we use number lines as our main tool for determining the result after you add two integers together, or you add negative, things like that. So the way it works, I'm just going to start from the basics. So we're going to add positives together, which I know you guys can do, but we're going to start from there. We're going to basically examine the different scenarios where you start adding two negatives, you add a positive and a negative, things like that. So here I've got my number line. I've got 2 plus 3, and I've got my number line. So since 2 is the start of, I'm reading the question, like I'm reading it just like a book. So I'm starting. My question starts off at 2, and then we're going to add 3 more. So the way the number line trick works is you identify where you start. So that's this number 2. So therefore I start here. And then I got to add 3 more. When I'm adding, I move higher up. I move to a more positive number on the number line. And in this case, I'm moving up by 3. So 1, 2, 3. And that gives me an answer of 5. Now I know most of you are very like, 2 plus 3, it's 5. I understand. Let's go to another example. Here we've got 2, and we're adding a negative number. So same method. We start off, I'm reading the question, reading it left to right. So I start at the number 2. So here's number 2. And we're adding, but I'm adding a negative. So if I'm adding a negative, I'm actually going the opposite. So here I'm actually going to be going backwards by 1. And that gives me an answer of 1. That's my final answer. So here we go. Let's go to a different example where I've got 2 negatives added together. Same strategy. We read the question from left to right. We start at number 2. So I've drawn my number line already. Here's where I'm starting. I've got a negative number, and I'm adding a negative. Now, to some people, they get confused when we're doing this, when you're adding a negative. And the way that I try and make sure I keep my head straight, like which am I going more? Am I going the positive direction? Am I going the negative direction? The way I keep my head straight is I like to think about my bank account, which is in a very sorry state right now. And so if I start translating it into banking, I think you'll get where we're going here. I start off with a negative $2 bank account balance, meaning that I owe the bank $2. And then I'm going to add another debt of $2. So you can see, like, that's bad. That's going in the wrong direction. So if I'm starting off in debt and I'm adding more debt, then I'm going this way. Okay, so when we're subtracting, or if we're getting more negatives, then we're operating towards the left-hand side. So I get an answer of negative 4. Last one here we've got to work with. I've got 2 negatives, but we're subtracting. So what's the deal? So let's go looking at, I start at number 2. Sorry, I start at negative 2. So I start with a debt of $2. I owe the bank $2. And now I'm removing a debt of $2. So I'm going to be okay, because my debt is being removed. I'm getting my debt of $2, negative $2, and I'm taking away another debt of $2. So in this case, you can imagine that these 2 negatives are going to somewhat interfere with each other, and we're going to operate in that direction. Okay, so you could almost imagine that this is the same translation, so same type of question is going to be the same thing as negative 2 plus 2, meaning that this negative are kind of canceling each other out here. And so that gives me the answer of 0. So that's what we're doing. I don't think I did this example as well as some of the other math teachers. So if your math teacher has done examples like this, then you should probably follow their lessons. My style is, I'm still the new guy on the block, so learning how to teach things in the best way possible. So they've been doing it a bit longer. So next question I had was from, this comes from Archie. He wants me to show how to solve question 10 from the complex unfamiliar, CU. He wanted me to show how to solve question 10 and question 11 from part B of the practice test. Oh boy, I don't want to take too long on solving this because remember, I'm only sort of dedicating half an hour. Well, I might go a bit over time if we need to, but I'm hoping only spending about half an hour of my time. So actually, I'm only going to work on question 10. I don't think I can do this question very nice. Like, I think the solutions that has been provided to you has more of a, it's more elegant. It's a really nice proof. It's nice. But I can tell you about what goes through my brain, and maybe what I'm thinking through you can sort of learn from. So for the rest of us who haven't got the practice test in front of them, this is the question. So question 10, A and B are both integers. So an integer is a whole number that could be positive or negative. When will A take away B always be negative? Now, we haven't done a lot of letters. Okay, this is basically the first steps into what we call algebra, where we use a lot of letters to be a temporary placeholder until we can put the real numbers in later when we want to. It allows us to do the calculations without having to actually stick in some of the numbers. Right. So what goes through my mind is I'm trying to unpack the question a little bit to try and, at first I was looking at it just, I haven't seen the question, so I looked at it literally 20 minutes ago. And what went through my brain was I was trying to unpack whatever I could from the question. I think even the practice test itself reminds you to keep using the keyword strategy, where you look for keywords and then you look for an equation and then you do the work and get your answer. I do something very similar when I work with my senior students for chemistry when they're doing some big math problems for their chemistry. So what I did is take away that. So I'm just swapping the letters for an empty box because remember, it's just a placeholder. We don't really know what the numbers are. They're both integers, but integer means a positive or negative number. So these are some of my clues. Now, the next thing that occurred to me is like, well, I don't know the answer straight away, but maybe I can do a little bit of testing in a way and see what shows up. So what if I've only got two numbers and these numbers could be a positive or a negative, then maybe I'll just run a few scenarios and see what happens. Okay, so I get two scenarios. So for example, I could have if A is positive and B is positive, does that give me a negative number? Well, I'm just debating in my mind whether to do the whole, working on the paper. It will take a long time, Tom. Sorry, is Archie there? So I don't know if I'll dedicate that much time, but I'll do a couple, and then you can sort of imagine how we solve the rest of them. So I just basically made a list for myself, all the possible scenarios where A take B. So I have okay, so Archie, so I just went down the page like this. There, I think in total that I thought of was about 4 different combos. So both positive, negative positive, positive negative, and negative negative. So those are the 4 combos I was thinking of. And then I did a bit of thinking. So if A was a positive number, take away a positive number. So if I go like, 2 take 5, does that give me a negative answer? Well, yes. What about 3 take 2? Does that give me a negative number? No. So if these two are positive values, then it'll only become a negative answer if A is a smaller number than B. So if I go 1 take away 2, that gives me negative. 2 take away 20 will give me negative. So in this occasion, it'll be negative if A is smaller, if A is smaller than B. So I found a scenario where this, A take B will be always negative. And then I keep going through my list of other possibilities and see if there are other occasions where that is possible. So that's the way I approach the problem. I don't think it's as nice as the solution sheet. Well, I think Miss Appleton wrote them, so she's really good. And actually, I'm not going to do question 11 because that looks like a lot of hard work. And again, I want to answer as many questions as I can rather than just doing a whole 30-minute session on solving the most difficult questions on the test. Thanks, Archie, though. I got another question from Bella from my class, and she was interested in working with that table from section B, question 3. You know, that one where you got a starting balance and you've got your spendings and deposits and withdrawals and stuff like that. So Bella, basically the way it works is you start summing them together. So if you look at the question, so if you're watching this now, you might want to get your question sheet up. I tried to print it, but I had no luck. It's not an easy thing to print. So if you have it with you on the screen, you can see where I've pulled these numbers from. So I took the $86, $86, and then I looked at the next row. And if I pull out, I'm just going to look at the thing itself as well to remind me. If you've joined in to the chat just a few moments ago, I'm answering my emails first, and then I'm coming to the chat feed. So if you're asking me questions, I will get to them. I'm just going to do this last answer to the emails I received first. So I've got, so you can see at the 1st of June, the starting balance was $86. So I wrote down that first line. Then you go to the next row of that table, you can see 5th of June, the transaction was a deposit. Deposit means that you're putting money into your bank account. So you can sort of translate what that word means into maths. It's an addition. And you can see it itself, like the transaction thing has plus 25. And then there's a space next to it. So we just got to figure out how much that is. So I started off with 86 and my deposit of 25. What's my new, resulting bank account? How much is in there right now? So I just do, I'm not as quick at this. I know that some of the kids are much faster. So I go 6 plus 5, that gives me 11, and I'll just tuck that over here and add it in later. So I got, oh, sorry, no, I don't put it there, I put it here. God, I'm not very good at this. 8 plus 2 gives me 10, but I had this little 1 here, so it becomes 11. Is that the same as the, did I do that right? I'm getting a different number. 6 plus 5, that's definitely 11. 8 plus 2, that's definitely 10 plus that one. Yeah, interesting. Okay. I think I received an email this afternoon that there was an adjustment to the solution sheet. So perhaps that was probably part of it. Anyway, so my answer for the total balance for the 5th of June, mine is $111. So, and you keep going. So the next day, they went to the movies. That means I have to spend money. So we've lost $15. So I can just keep going down my page here, and I'll swap to a different color again. And so now I'm just going to take away $15. So 1 take 5 I can't do, so I'm going to borrow. I'm going to make this 11 here, and this is going to be a 0. 11 take 5 gives me 6. 0 take 1, well, I can't do that, so I'm going to borrow again. So that's going to be 0. That's going to be 10. 10 take 1, that gives me 9. So I got 96 for the next one, and so on. And that's how you basically are going to fill in question 3. I'll see how we go with the chat feed. I'm just going to go and have a look at probably the longest chat feed I've seen ever. Oh, it's not too bad. It's not too bad. Not so scary. Hey, Freddie, thanks for coming, and Karen, and FaZe, and Dropsa, and okay. So I'm starting at the top of the chat feed. So if you've listed a question at the bottom, I'll eventually come to it. So could you please explain to me index laws? My teacher's explanation makes no sense. Index laws. Oh, FaZe, this is for my grade 7 math class. I'm so sorry. I don't want to confuse my intended audience by doing year 8 maths on this live stream, FaZe. So I'm sorry. Okay. So I'm going to scroll through. Horse, just a random dude. Okay, a random dude. Drops. How about dividing and multiplying negative and positive integers? Okay, so multiplying and dividing negatives. So if I've got 4, let me just do a few scenarios here. Again, I apologize if this is very boring. I didn't intend to have so many people show up today. So I do the same. 4 divided by 4. 4 divided by. Hopefully I can solve these ones on camera without getting stuck. All right, so I'm answering Dropsa's question. How about dividing and multiplying negative and positive integers? So I've done a few scenarios. So here's the multiplying, and then here's a few that for dividing. If I've got 2 positives multiplied together, well, the answer is going to be positive. So 4 times 4, that gives me, oh God, what am I doing? 16. Not going well. We got 4 times a negative number. In this occasion, a positive times by a negative wins. So my answer is going to be negative. 4 times 2, that gives me 8. So I get answer of negative 8. That's the thinking that's going through my head. If you think about it, I've got 4 times the debt of $2 in my bank account. That's huge. It's still going to be a negative answer. So you can almost do that sort of bank account thinking to double check your direction, whether you're going the right way. If I've got 2 negatives, then in this occasion, the 2 negatives will annihilate each other, meaning they cancel out. So a negative times a negative will cancel. So I've got basically answer, it becomes a positive 8. Same sort of tricks apply when you divide them. So if I scroll up, positive divided by positive, I'll just get positive. So 4 divided by 4, I just get an answer of 1. Oh, by the way, if I actually do the basic algebra wrong, like I can't multiply, divide, or add and subtract, forgive me. It's a bit late. 4 divided by a negative number. So I got a positive divided by a negative. Negative wins. Same as we had up here. Positive times negative, negative wins. Positive divide by negative, negative wins. So my answer is going to be negative. 4 divided by 2 is 2. So my answer is negative 2. Scrolling further, I've got a negative divided by a negative. And this, same as above, the 2 negatives will annihilate each other. So that will cancel that. And so basically 4 divided by 4, that's just 1. I hope that helps you, Dropsa. Next question, scrolling through. Let's see. Hey, FaZe, keep it civil. Saying some very mean things out here. Marzipan, g'day. Katie, what are the steps to dividing fractions? That's a good question, good question. Okay, so we'll do that. Let's divide a fraction. Now, dividing fractions is very simple to do, but you might have to do a little bit of extra fixing depending on what kind of question is thrown at you. So the basic one is if I've got 1/2 divided by 3. So let's say I'm dividing this where I got a fraction divided by a whole number. The trick is that you've got to use reciprocals. It's much easier to do divisions when we have fractions. It's so much easier if we can transform this into a multiplication problem. So with a bit of hocus pocus magic, I can use the power of reciprocals. Reciprocal is basically a fraction that's been flopped upside down. So if I flop this upside down, it'll be a 2 on top and a 1 on the bottom. But I want to flop this one, not this one. So if you start from here, divide by something, you want to flop this one upside down. But this one's not a fraction yet, so I got to fix it first. So I want to turn this into a fraction, so then I can flop it upside down into a reciprocal. And when you flop them upside down, you also flip this thing into a multiplication sign. That's basically how it works. So I can rewrite this question. That's the same thing as 1/2. And I take that 3 and turn it into a fraction. So 3 is the same thing as 3 over 1. That basically means 3 divided by 1. If you put that in your calculator, you'll just get 3. So that's the same thing as our original question. I'm just fiddling a little bit. I'm just changing it into a form that makes it easy for me to solve. Now, if I flop it upside down to turn it into a reciprocal, when I do that motion, I also have to change this divide sign into a multiplication. So if I turn that into reciprocal form, this becomes the multiplication sign. I leave the other one alone. Don't touch the first one. So if you got this, if you had this divide by that, leave the first one alone. Okay, 1/2 times by the upside down, which should be 1/3. Now, you know the multiplication for fractions. You basically smoosh the numerators together and you smoosh the bottom denominators together. So I get 1 times 1. What's that? That's just 1. And you got 2 times 3. So that if I gather that together, I get an answer of 1 on the top. 1 times 1 is 1. 2 times 3 is 6. I algebraed that right. So there's my answer. Let's see, what if I've been given a fraction divided by a fraction? Well, if you have that, then you basically start from here. So same working. The only other type question that I can think of right now is that maybe you get presented a mixed number, and then you got to divide that. In that case, you have to translate it into a form that's easy to use, where you basically fix the mixed number into an improper fraction. So let's say 2 1/3 divided by. So let's say I've got a question like this. So they're technically fractions, but this one's not quite the same. So what I want to do is I want to absorb this 2 into my numerator to turn this into an improper fraction. So it's all one fraction. Then I can just do the flopping upside down and changing this to a multiplication sign. So I think you've been taught how to do that. One way of doing it is this is equal to, just going to circle something here. Just to make it easy to follow. So I've colored the numbers, and hopefully you can follow along. Oh God, this is very icky. Got markers all over my bench. That'll be 2, which came from the 2 holes. But each hole is being compared. Each hole has been cut into 3 slices. So how many slices in 2 holes? Well, it'll be 2 lots of 3 slices. So that's where this 3 comes from. And the 3 that was down there stays there. And that bit here from the top that was there in the first place stays. So I've got 2 holes that had been sliced into 3s. That makes it 6 pieces plus that 1, all over 3. And so I just copy the rest of the question as it was. And now let's work this. So 2 times 3 is 6 plus 1 gives me 7 over, that's a 7, not a negative. Sorry, 7 over 3, divide by a half. Oh God, I should. Now we just reciprocal the fraction and change this division into a multiplication. So this is going to be, I'll leave the first one alone. This is now changed because I'm flopping the other fraction upside down. So it becomes 2 over 1. So I get 7 times 2 divided by 3 times 1. So 7 times 2 is 14. 3 times 1 is 3. So here's how you do it. And from there, you can decide if you're going to do mixed number or not to present your answer. Okay, so I hope that answers your question. Whoa, the chat feed just exploded. So I hope that answers Katie's question. Hey, Jasper. All right. Can you do a percentage to fraction, hard questions or not? No. Jasper, I'm going to try and stick to the simple ones because, my expectation is that the people who showed up today for the live stream are the ones who need the extra help, not the ones who are, doing well and wanting harder stuff. Because if I start doing harder stuff on camera, I don't know. I don't think it's going to help the others. So I'm just, that was the plan, is that I want to help people who needed a bit extra. Okay, decomposes. DT, we can't do science during here. Let's keep it on topic. Let's see. Make the whole number into a fraction. Oh yeah, you were answering the feed while I was answering it. So I'm seeing lots of Dopser and Jasper and stuff. Will, oh, g'day, Will. And meaning of life is definitely 42, according to the Hitchhiker's Guide to the Galaxy, which is a film and a book, and I think a TV show. Anyone want to make a Kahoot? Science to the maths, quick maths. Jasper, can you be not confuse people with your memes where the 2 + 2 = 4? Can you stop doing that? Okay. Okay. All right. Well, I think I've caught up on the chat feed. So now to, yeah. If we don't have any further questions, do we? Besides the extra hard ones that I think Jasper or Will was asking about. I'll check my emails to see if anyone sent anything through. No, nothing in the emails yet. So Megan asks, can you help me convert a percentage to a fraction? Oh yeah, sure. So if I make up a number, I'm just thinking I may not be able to do this very well. So if I've got a fraction of 34%, percent is just, you see it looks very similar to this sign, doesn't it? We know that sign looks very similar to a fraction. So it's actually 34 out of 100. That's how it works. So percentages, if you say the name out loud, it's a bit of Latin, I believe. Per means out of, cent means 100. So if you say 34%, you're actually saying 34 out of 100. So straight away, you've already turned it into a fraction. From there, you have to do a bit of figuring out to simplify. So you could probably divide top and bottom by 2 and see where that takes you. Where are we at to? Airspeed velocity of an unladen swallow. Well, it depends if it's European or African. Jasper, I'm disappointed. It's African or European. That's how the line goes from the film. Disappointed. You need to do that for homework. You're going to watch Monty Python and the Holy Grail. Holy Grail one more time until you get the line right. I'm sure Mum and Dad will enjoy it. How long is the stream going for? 25 minutes, roughly. I started at 7 p.m. 24 miles per hour. Okay. Since I haven't had any new questions showing up in the feed, I might have another stab at a question from the... Oh, and we got a new one from Megan. What if you times a percentage by a fraction? Okay, so let's try that. To do this, in its current form, I can't do it. But if I translate this into a form that's really easy to work with, I know in my head that this could be written as a fraction, as I showed you just a few moments before. So if I translate to a fraction, then that means I'll have a fraction here and a fraction here, and I know how to multiply that across. So that'll just be 34 over 100. And then we smoosh the numerators and smoosh the denominators. So we got 34 times 1, all divided by 100 times by 4. And from there, you try and simplify and knock things out and simplify. Oh, thank you, Cujo. Cujo Maths. Oh. I'm trying to figure out who Cujo Maths is. I think he might be one of the math teachers. Oh, well, thank you for that. I put a lot of my effort into making the videos as best and clear as they can be. It's not easy to do what I'm doing in those recent video clips where I'm doing the maths. It takes quite a bit of software trickery, really. Okay, what other questions have I missed? Ask every question in the maths book. Thanks, William. You're a big help. Limited 200 words. Just love lashes. By painting. Oh, Jasper, thank you. It's Mr. Cujas. Nice. Sure, I can show what I'm doing, but I don't think you'll be able to copy exactly what I'm doing. I'm pretty tech savvy with the software. You're welcome, guys. If you are good, like you've come here and you've had your questions answered, then you're free to go. So you can leave me all alone. But I've got a little bit of energy left to do a couple more, I think. So I might try and pick some from the practice test paper, and I'm going to continue on from Bella's question. So let's go to question 4 from part B. Question 4, place the following fractions in ascending order. So we've got 5 over 2, 5 over 8, 5 over 55, 5 over 5, 5 over 7. Okay, so that's the question from 4 on section B. And let's unpack the strategy and how to solve this. Well, first, ascending order means you're going from low to high. So you're literally ascending the staircase. You're going up. You're going up in value. Which one is the big and which one's the smallest number? And you work your way to the biggest number. And we can't tell. We can't currently tell in their current form. So we need to translate them somehow. And the way we're going to translate them, and I don't know if I can do this quickly on camera, but the way my gut was like, oh, I've got to convert all of these fractions so that the base, sorry, the denominator, we've got to make sure that we convert those bases to the same number. Now we can compare apples to apples. Currently, like apples, oranges, fruit, veggies, and they're all very different from each other. We can't really compare them. So my thinking here is that can I scale up some of these maybe scale down some of the others. I don't know. We'll figure it out. But can we scale some of these such that their denominators are the same? And one of the ways we look for is like, what is the lowest common factor? I think that's the LCF, I think it's called. What's the lowest common factor that I can transform all of these bases into? So can I convert 5/2 into like a base 4? Yeah, I could double it to make double top and bottom to turn that into like 10/4. But that's not going to work for everything here. So what if I go? I can convert this to a base 10. Can I convert this to a base 10? No, I can't. Can I? Well, let's start with the odds. I'm not mathsy enough to instantly know what's the lowest common factor. I can't do that. Just honest to God. So I'm going to go on a. It's a strategy. It's not a great strategy, but it'll get you somewhere. It just takes a little bit more time. It's like when you have to move a really big object down the staircase. You don't know exactly how you're going to do it because you have to rotate the fridge this way and then tip it over on its end, and then I get somebody down behind to receive it and lower it down. You can get there without really knowing how to do it. If you just think about, well, first we've got to move the fridge to the doorway. Let's just get to the doorway. Now the fridge is in our doorway. Okay, well, now all we got to do is try and figure it to get it somehow to the next landing. So you sort of think, okay, well, it has to go this way because it can't go left, you know. So doing it little bit by bit, just going one step forward. And for me, what I'm thinking on this problem is that I'm noticing some of these numbers are even and some of the bases are odd. And I'd like to start off where all of the bases are odd and then see where I can see, maybe it's easier for me to see if I can find a common factor that I can transform them all into. So that's what I'm thinking. So I want to try and just, for starters, turning them all into evens. So 5/2 is already even. 5/55 gives me, I can translate that into 10/110. Yes. 5/5. Well, that's like 10/10. 5/7, if I double top and bottom, 5 times 2 is 10. 7 times 2 gives me 14. Okay, so now I'm there. So I'm thinking that the question is going to require a bit of effort to work on this number and this number. Because I want to work on these numbers here to the point where I can get them to I think I need to make these bases larger. This one's pretty big, so maybe I'll leave it alone for now, but can I make these bases pretty big? So I'll just keep going. And so you can solve the problem. It's not nice, it's not fast, but it is a method. So if you're doing your test paper and you find a question like this and you're like, well, I don't know exactly the common factor I can use, but I know that this method can probably get me there, but it'll take a long time. You might sort of leave that one behind and do the rest of the paper that you can. And then when you have some time remaining, come back and you start fiddling. So I'm just fiddling. So if I double this one again, so that makes it 20/28. 10/10, I can turn this into 20/20. I'll leave this one alone. Make this one, let's see, 8, 16, 28. No, is it 24? 8, 16. Oh God, the chat feed is probably crucifying me right now. I can't do my 8 times tables. But I can turn 5/2 into base 28 if I wanted to. So let's make this one the same as that one. So 2 times what gives me 28? Well, 2 times 14. 2 times 14 will give me 28. So 5 times 14. 5 times 14, well, 5 times 4 is 20. 5 times 5 is 5 times 1 is 5. 5 is 70. So now I've got at least 2 of these fractions on the same denominator. And for this one, I'm thinking if I could just figure out my 8 times tables. And here, because I can't do my 8 times tables, I'm literally going to do it the old school way. So I know that 8, 16 plus 4 plus 4 gives me 24. And then I get 32. Okay, so I could go to 32. Could go to 24. So 8 times 8 times 3 gives me 24. So 5 times 3 is 15. So I'm getting closer to making all these bases the same. And I'll just keep on fiddling like this down the page. And again, it's not the best method. If you are expert at your divisions, if you're expert at your times tables, I'm sure you could find the answer faster and better than I did. Okay, I'm turning to a chat feed if there's any people there who are not being mean and telling me how to do it. Thank you, Michael. You're an awesome man, helping me out. Maybe I should just like look at the live feed when I can't multiply. Okay. Where was I at? What number is the car on? What car? Section B, question 8. Okay, so Dominic wants that one. And Ellie's question. Did I miss Ellie's question? Who's Ellie? I feel like I missed something. I'm going to do Dominique's question, which is question 8, section B. Hopefully I can solve it on the camera. Section B, I think. Question 8. Oh my God. Everyone was saying this one's so hard. At the beginning of a walking track, a large sign showed 4 4/5 kilometers to the Strangler fig tree. Further along the track, 2 hikers saw a small sign that showed 2 2/3 kilometers to the strange fig tree. What is the percentage of the distance to the Strangler fig tree that has been walked? Okay. For this one, I like to use diagrams. I try and use diagrams to solve math problems. It's almost like it focuses your attention a bit. So I'm going to draw a line, and let's pretend I've got this little guy here. It's my hiker. And then I'm going to have this fantastic drawing of a tree. So I'm doing this. And I'm thinking, okay, so at the beginning of the track, the question says a large sign said 4 4/5 kilometers until you reach the Strangler fig tree. I don't know if that's what it looks like, but that's just a tree. So let's write that. So we've got a total distance of 4 4/5 kilometers. So that's that distance sitting there. And it says further along the track. So when to help Dominique, can you see how I'm always returning to the question? So I take a little bit, put a diagram, come back to the question, read it again, and I going bit by bit, just going backwards and forwards. I find that some kids, they will read the question and they'll start solving, and they'll never look back at the question, because the question might actually have a small, like, express your answer in decimals, or express your answer as a fraction, or something like that. So you need to be, need to always return to the question before you go, bam, answer. So it says further along the track, 2 hikers, small sign. So they've walked along a little bit. So now the hiker is somewhere along that length. And now the small sign said 2 2/3 kilometers left to the tree. Okay, so now I've got a new number, which means that from here to here is 2 kilometers. So I'm drawing my picture. I think I've got my picture right. What's the percentage of the distance to the friendly tree, to the fig tree that has been walked? So how much has been walked? Well, that would be, that distance there is how much has been walked. So I've got to find out what that number is. And it asks us what's the percentage of that distance to the tree. So I've got to figure out how much this is relative to the total length. So let's just figure out what that distance of travel was. So that's just going to be the total distance subtract the distance remaining. So that's going to give me that number. So I'm going to do, you've seen me doing addition and subtraction stuff, so I'm just going to go real fast, as fast as I can. Take away 2. So I'm doing this. So that number in total, take away this bit here. They're both mixed numbers. I can't subtract that, so I'm going to transform them into improper fractions. That gives me 4 times 5 plus 4 over 5. Take away 2 times 3 plus that 2 on top, all divided by 3. So I get 4 times 5 is 20, 24 over 5 minus 2 times 3 is 6, 6 plus 2 is 8, 8 over 3. Okay, so now I've got that, and I'm stuck because the base of those denominators are not the same, so it's apples and oranges. Let's fix that. So I'm going to look for the common factor. I can turn 5 into I can turn 5 into a 5 or a 10 or a 15 or a 20, but I want to find out what base can be the same as this one. I can turn 3 into a 6, into a 9, into a 12, into a 15. 15 works for both. So let's transform them both into a base of 15. To do that, I'm going to multiply this by 3, this by 5. There's my working there to transform those two to the same base. And if you can watch this video afterwards and, oh God, can I do that division, that multiplication? 4 times 3 is 12. Carry that across. 3 times 2 is 6. 6 plus 1 is 72. 15. Take away 8 times 5. 40. So I'm now here. Now I can actually, it's apples to apples. So now I can do that subtraction. So I get 72 take 40. Well, I can't do that in my head because I'm not fast enough. So I'm now going to do it like this to try and solve it. 2 take 0. 2. 7 take 4. 3. So I get an answer of 32 over 15. That's how much distance has been traveled. But I now have to figure out how much is that relative to the total distance. So I'm just pausing to think. How would I do it versus how it should be done or has been taught? Okay, I've got it. Just took me a minute. Okay, so if I've got to express the distance traveled by these guys, this distance here is this number here, then, and I've got to express that as a percentage of the distance traveled to the tree. That means I've got to go this number over this number, and whatever that fraction is, I've got to translate that into a percentage. So I basically got to have this number over this number. Now, this is not going to work because it's still mixed format, but I already changed it over here. So 4 and 4/5 is the same thing as 24 over 5. So I could actually take that fraction, this fraction, and do a division. to sort of think about it as a fraction. Yeah, let's do that. So the fraction of how much traveled compared to the whole, so that'll be 32 over the 15. So here's the next step, which I've done color-coded. So I've taken distance traveled divided by the total distance to give me a sort of comparison to how much has been done. Now I'm going to do the flipping this upside down and turn it to multiplication sign, but I am noticing that it's not apples to apples, but actually if I'm turning into multiplication, it doesn't really matter. I'm just thinking a step forward that once I flop this upside down, it's now multiplication, and multiplication doesn't care if the numerator or the denominator is not the same. And I've run out of room, so I'm going to run to the next page. So I've got, that basically is 32 over 15, 24 over 5. So I just copied it again. Now we're just going to do the reciprocal technique. So I flopped it upside down, turn it multiplication, smoosh it together, which is going to test my ability to do multiplication. 2 times 5 is 10. 5 times 3 is 15. 15 plus 1 is 16. 24 times 15. Oh, God. I'm just going to go straight to this. You know what? I'm going to cheat. I'm going to use a calculator because I can't multiply double digits together. This is so sad. I don't know the method. I'm not used to doing things like that. I'm going to scroll to the Brains Trust, also known as the chat feed. Can I get Jasper or Will? Can you guys do for me 15 times 24? If not, I'm going to punch in my computer here. 360. 360. So there's my... Yeah, Jasper, it's going a bit longer. Most people have had their questions answered. Now I'm just doing bonus material. Okay, so now I got to this stage. I can knock out 2 zeros. That gives me 16 over 36. And now I can turn that to percentage by using the Mr. Bygraves technique, as I like to call it. And that's when you basically multiply it. If you multiply any fraction by 100 over 1, that translates your answer into a percentage. So now if I follow that through, that gives me 1,600 all over 36. And I can't do that in my head, so I could do long division, or I might try and factorize and cancel out terms. So 1,600 divided by, oh God. You know what? Doesn't really matter. You solve the rest. So as long as you can simplify and actually figure out what that answer is, that'll give you your answer in percentage. Done. Okay, that answers that question. We're scrolling back up to where I was. So that's Ellie's question. That's question 8, section B. I hope that answers your question, Ellie. Ted Cruz. Faze, be nice. Thank you, Michael. You're an absolute champ. Thanks, Luke. Can I make a science live stream one day? Yeah, I'll probably do that sometime soon for the grade 7s doing their science, write-ups. Review. Oh. Okay. Thank you, William. Oh, so the answer is 44.44. Nice. So you guys say that that's the answer to that division. Awesome. Well done. Okay. You did it in your head. Oh, I'm so jealous. Use the calculator. That's also... Okay, I think that's it. I caught up to the chat feed. And it's now pretty much 8 o'clock. And my wife is just about to come home. So I'm going to call it a night, guys. I hope you enjoyed the live stream. Thank you for hanging around and keeping me entertained by not leaving me all by myself. So I'll catch you later. Bye.